Let's talk about a really interesting service that Microsoft offers inside Azure called Azure Arc. Azure Arc allows you to manage virtual machines and physical servers and containers outside of Azure as if they were Azure VM servers and containers. So it's cross-platform, hybrid VM and container management. What Azure Arc allows you to do is to use one interface for management of your servers across your environment. That includes the Azure environment, and that's not Arc specifically, but your on-premises environment, Amazon AWS, Google Cloud, wherever you have servers and services running, you can manage them inside of Azure. You can use what are called VM extensions. So if you're used to working with extensions for log analytics and for running scripts and managing operating system updates, you can do that inside of Azure for these servers that are outside of Azure. It also supports databases. So if you've got SQL Server and SQL services running outside of Azure, you can manage them inside as well. Not only for servers, but for clusters, which are containers. And you can even set up some of these passive management things, such as policy, where you can enforce certain governance on these machines. So let's talk about those couple of different platforms. So one is what you can call a server platform. So you can manage both Windows and Linux physical servers and virtual machines that are running outside of Azure using Azure Arc. And as I just said, you use what's called VM extensions for these Windows and Linux VMs outside of Arc. Now, what does a VM extension get you? You can start to collect log data and put that into a log analytics workspace and use Azure Monitor to monitor log data. We're going to talk about Monitor in the next section. You can use some of the performance and analysis tools inside of Azure to analyze the performance of these servers. You can download and execute scripts. So sometimes when you're creating a brand new server, on startup, you want to install some software, you want to perform some task, copy some files. Those are on start scripts. And so you can do that in Azure, connecting to these machines, again, on premises and other cloud providers. And you can even do things such as refresh security certificates using Azure Key Vault. And not just servers, but containers. So if you have a Kubernetes cluster running, then you can attach Azure to those Kubernetes clusters, again, anywhere they are. So if you go into the portal, you can find Azure Arc. You can see that there's a lot of information that can be found from within the portal, linking to the documentation. And there is no charge to add these machines. So add your infrastructure into Azure for free. You can see on the left here, it's working with not only machines, Azure Stack, which is your on-premises private Azure cloud, Kubernetes, VMware, it also supports, and SCVMM if you've got servers managed in bulk like they are. Now, you go in the Azure Architecture Center. We don't need to get too deep into this, but here's just an example of you have a number of servers that are on premises. These are virtual servers, physical servers, SQL servers, and managed instances even. And then you've got other cloud providers that could be AWS or Google Cloud. And you've got, again, Kubernetes clusters, SQL virtual machines, managed instance. And all that is represented inside of Azure Portal. They look like resources. They're represented by resource IDs inside the portal. You can use Monitor. You can collect log analytics. Use Sentinel to ensure your security is evaluated across all those platforms. Policy to enforce governance, etc. So you have all these features for servers that are not even Azure servers. Now, for a developer, it's pretty easy to understand the concept of backing up your code. So when you've worked all day and you've written some code, you check it into a source repository like GitHub. And that way, if anything ever happens to your computer, then you got it stored centrally and it's backed up and you can keep versions and things like that. But how do you restore your configuration in Azure? You've got 3 VMs and 2 web apps, and you've got a SQL database, and there's a virtual network, and these are the subnets, and these are the firewall settings. How do you back all that stuff up? And you can probably do it piecemeal. But one concept that is come out in terms of keeping your infrastructure, your design and setup within Azure backed up is this concept called infrastructure as code, or IAC. So when we're talking about infrastructure in this context, we're talking about all of the resources running in your Azure account. It's the VMs, it's storage, it's databases, it's all the network and network settings, the firewalls, everything that you consider to be the infrastructure of your application. That's what we're talking about. You've obviously got your applications, the code running on top of it. That's backed up into a source repository. You've got your data that could be backed up into an Azure backup type thing. But we're talking about the settings and the setups. So how do you back up your infrastructure? So the answer, like I just said, is infrastructure as code. And basically what you do is you, as a developer would do, you create a file that defines your infrastructure. So instead of going into the Azure portal and manually creating a VM and manually choosing all the options, you write a script that creates that VM, or you use an ARM template to create that VM. And we'll talk about the options at the end of this video. But you use a file to create that, and then you just deploy that file. And if something happens to it, you can delete it and deploy it again. And if something happens to that, you can deploy it again. You could even move this virtual machine or whatever resource it is into another region. You can copy it. You can wholesale move it using this technique. So all you do is send your deployment to another region, and you've got the exact same copy of all the resources running somewhere else. Now, there is a related concept to this, to the infrastructure as code, called desired state configuration, or DSC. Now, the concept of desired state configuration is once you've set up your environment, let's say your production settings, you have this many VMs, it's got this much RAM, this much hard drive, these are all of the settings for everything. What becomes challenging is managing and maintaining that over time, because somebody might go into your Azure account. Let's say they're trying to debug a problem, and they'll go in and they'll flip a switch. They'll turn on more verbose logging. They'll turn on some type of diagnostics that gets data going into Azure Monitor. They'll start to diagnose the problem, and then they will forget to undo that. Or they will do some change in Azure natively that is not reflected in your infrastructure as code. And so they will, change the setting on a VM or change the setting on a web app, but you didn't update the file. You did it directly within Azure. So that is the concept of drift. And so over time, if you have a large environment within a place like Azure, you may see things start to drift. The configurations that it had when it first got set up, after 6 months, after 12 months, after 18 months, will be slightly different. And that's a drift from your original setup. That could compromise security. That could make it harder to restore. Let's say you do have an event where something gets corrupted and you need to recreate that environment. But if it doesn't match your original setup in your infrastructure as code, then it may not work. And so what you should do is do these things by files, which could be ARM templates. It could be Azure Bicep, which is a abstraction on top of ARM templates. There are third-party software such as Terraform that can do deployments to cloud platforms. There are automation tools like Chef and Puppet, which are open source, that you can use when it comes to configuration. You can even write scripts. Like if you sit down with CLI or PowerShell, you can have it create your virtual machines and have it create your storage accounts and things like that. Or it could be any type of code that you can come up with as a developer to interact with the Azure APIs to create the environment. Now, that's obviously less ideal to do such code like that. To use ARM templates or Bicep or Terraform, those are industry standard ways of maintaining your environment. You can check those into GitHub just like you do with your code. You can track changes over time. It has all the benefits. Little bit extra effort to do it by file over doing it directly in the portal, but you get the benefits and the discipline of making your production environment documented and reproducible in an emergency. Now, one of the Microsoft recommended ways to manage infrastructure as code is using what is called ARM templates. Now, the abbreviation ARM, you'll see this in various places within Azure, stands for Azure Resource Manager. And really, it's just a catch-all name for the engine that runs behind the scenes that are deploying and managing resources. So as you may know, you can log into the portal, you can create VMs, modify VMs, delete them. You can also do the same thing using PowerShell, using CLI, using custom code like in Visual Studio. There's also URLs like REST APIs that you can call. And all of that is basically managed using Azure Resource Manager model, which is basically an engine behind the scenes that accepts all these commands and runs them in the exact same way. There's no different method for deploying in the portal that's used behind the scenes compared to what's using PowerShell. Now, ARM templates are basically pieces of code, files that allow you to define what your infrastructure needs to be. And so when you create a resource in the portal, like a virtual machine, it's going to create an ARM template and it's going to deploy that ARM template. So ARM is the deployment and management service for Azure. It is a management layer that allows you to either create, update, delete resources, and these are packaged in what's called deployments. And all of these actions for various channels that you take to manage your Azure resources all go through the ARM layer. Let's show this as a diagram. You can see the portal, PowerShell, CLI, Bicep is up there. The REST clients, which are the URLs, that all goes to a single point through the Azure Resource Manager. And once you've validated the authentication of who's doing the request, it's going to create a web app, it's going to create a virtual machine, it's going to do all those other services behind the scenes. So let's take a look at these JSON files, the ARM templates, as an example. And this is just a snip, a small snippet of a JSON file that's an ARM template. In this particular one, we can see that there are a resource that's being created that's actually a storage account. So I can actually, it may be difficult for the common person to look at this and get anything out of it, but I can see it's mentioning resources and type is Microsoft.storage/storage accounts. And that's the consistent type when you want to create a storage account. And we can see that it's getting the name from a parameter, it's getting the location from a parameter, and it's going to deploy this as a hot tier storage account. And down by the bottom, we can see it's actually setting up a container, blob services/containers, and the name is coming in from a parameter as well. And so this is an example of creating a storage account using an ARM template. This is infrastructure as code. Once you've created these templates, you can store them in your Git repository. You can deploy them again and again. And as you see, it does take parameters. And so you can just pass in different parameters if you need to create multiple storage accounts or deploy them to different locations. You can actually do things a little bit dynamically based on parameters, but have the same settings and have everything standardized and repeatable. So in this video, we're going to demonstrate working with ARM templates that we were talking about in the last video. To do this, I'm going to create a resource, or at least I'm going to go through the process of creating a resource. So I clicked on the Create a Resource button, and I'm going to choose a storage account for the purposes of this demo. Now I'm going to go through the process of creating a storage account, just like I was creating one. I'm going to call this AZSJD ARM demo. And when you create a storage account name, it has to be unique across Azure because storage accounts have URLs that can be used to access them, and they have to be unique. I'm going to make this a locally redundant storage. Now I could go through this. I could change all of the settings, whatever settings that I want to choose. It's getting, over the years, more and more options when you're doing the creation of storage accounts. So I can turn off all the soft delete stuff, for instance. And I get to the review and create screen. So this is the point in which you would normally hit the create button to create a storage account, but I'm not going to do that. I'm going to choose this download a template for automation that's in the bottom center of the screen. So what Azure has done is they've taken the wizard that I went through, filled out all of those fields and checkboxes, and they've turned this into this JSON, JavaScript Object Notation file, JSON. And the file has a predefined format. It's got parameters that are like variables. And you go down here and you get into the resources section, and we can see here that a storage account is being created. So it's obviously intended to be machine readable. A computer is going to process this. But a human can read this too if you know what to look for. Now you might notice that there's these parameters. So the name is not being given this hard-coded name. It's actually being pulled in from a parameter. So an ARM template actually consists of the template and also the set of parameters that we want to pass in. So when I go on the parameters tab, I can see the location, the name, the type, the access tier, all of the true and false values that I've selected, etc. All right. So what I can do is I can save this template and the parameters to my local machine. So if I click the download button, a zip file will download to my local containing both the ARM template and the parameters files. Now, from my local, I can use PowerShell or Bash CLI to deploy this. If I just wanted to deploy it the way that I intended to create it, I can just do it without modification. But if I wanted to deploy this repeatedly, let's say I wanted to create 200 storage accounts, I could write a little script in PowerShell that would vary the name, storage account 1, storage account 2, storage account 3, and just deploy them repeatedly. Alternately, I could modify the template to create 200 copies in a single deployment. That's also something you can do. So there are PowerShell and CLI programs that you can start with. This is in GitHub, and you can then modify to your needs. Now, that's one way of working with ARM templates, is on your local machine. Another way is through this, what they're calling the template library. Now, this is in the midst of changing. So when I say add to library, what it's actually going to do is it's going to create a resource that gets stored in one of my resource groups. And this is called a template spec. Okay, so this has obviously been implemented. So I'm going to have to call this a storage template. And I'm going to have to find a resource group to put this in. It has to be a resource group that you're not going to delete if you want this template to stick around. You can give it a description so that you'll know in the future what this was intended to do. And the only other requirement here is a version number. So you can obviously have a version 1, a version 1.1, a version 1.2, etc. And if you need to make changes, you can track those changes. We have another opportunity to edit the template, which we won't do. We can use metadata, which we won't do. And so at this point, when I click create, a template spec is going to be created in this resource group. and I'll do that. Now, this isn't the only way templates work, and I guess the purpose of this course is not to teach you how to use templates in practice. But once that's been created, let's go into the ARM demo resource group. Click refresh. And we can see the storage template that we just created has been created. And if I go into it, I can then choose to deploy it. So if I want this resource to be created, I just say deploy. Now in this situation, it didn't keep the parameters. You can see they're all blank. And so what you need to do is you need to re-enter the parameters or upload the parameters into this template. And so once you deploy it, again, you can reuse the template again and again with different parameters. As you can see, there's versioning and stuff built in here. Now, perhaps worth mentioning that there is also a template, a library here, templates, that is, it says preview, but obviously when I was saving the template just now, it did not save into here. So Microsoft has moved on to this template specs model, which is a slightly different. If I go into template specs, I can see the template that I just created. So ARM templates, again, ARM is the way that all Azure resources get created, modified, deleted, and interacted with. And so you can create these text files called template, ARM templates in JSON format. You can save them, edit them, store them in your Git repository, track them over time, track changes. And this is a way of storing your infrastructure as code. So in this last section of the course, we're going to be talking a bit about monitoring tools that Microsoft Azure provides to monitor your subscription. Now, the first of these tools is called Azure Advisor. And we can see it on screen here that there is an overview screen that gives you sort of an overview about the recommendations that Microsoft might have specific to your subscription. So these are not generalized recommendations. They're actually analyzing your usage of Azure and making recommendations for that. You can see that they're broken up into 5 overall categories here. We have cost recommendations, security recommendations, reliability, operational excellence, and performance. Now, I'm running this on my test account here, and so I'm not seeing a lot of recommendations. But if we were to go over and look at what kind of recommendations they make, Microsoft is going to look at a lot of different categories: AI services, analytics, compute, all the way down storage, web, etc. And they're going to basically be analyzing your account to see if you can save money. This is the cost savings category. And in particular on the AI services, it's looking at a computer vision resource that isn't using read usage in the past 30 days. And so they're looking at your account to make recommendations of this, or the speech service, or the translator service. So there are literally hundreds of different recommendations that it's going to analyze your account to see if it makes sense for you to follow them. Now, similarly, it's going to do the same thing against security recommendations. So if you're running virtual machines with an RDP port open, it's going to make recommendations around that. And it's going to be using a Defender for Cloud service in order to get that. Now, reliability basically is going to be how much uptime you're going to see, any outages. For instance, it's telling me I don't have service health alerts created on this account, and we haven't even using soft delete against the blob data. Again, this is a test account, but these are examples of things that could cause downtime if something was to go wrong. And so these are the reliability recommendations. Now, operational excellence obviously are best practices that Microsoft likes to see. So these might not be cost savings. In fact, it might cost you a little bit of money, but they want you to, for instance, use the more recent version of a particular API. Not having a monitoring workspace is going to be an issue. Deprecated Kubernetes, things like that, things that are not necessarily saving you money, and maybe not necessarily security threats at the moment, but they're not operationally ideal. And finally, it makes a sense that they're also making performance recommendations. So for instance, if your virtual machines or your web apps are constantly running at 80% utilization plus, then it might suggest that you upgrade to a higher tier because you're running close to the edge of performance, for instance. We have determined your VMs are located in a different region than where the users are connecting. So as an example, having computers that are far away from their clients is going to be a potential performance issue. So these are recommendations that you don't have to follow. You can choose to follow, and Microsoft is going to be recommending them to you. And that's Azure Advisor. You don't have to do anything for this. This is just provided for you. Of course, if you are given recommendations, you can choose to follow them or not follow them. That's sort of your choice there. So, for instance, it wants me to create a service alert. It's going to tell me why. It's going to take me to documentation. And then I can basically decide, okay, I'm going to do this. So let's create a service alert on this account. I can click it. Sometimes, this is not always true for every recommendation, but it'll actually take you through the steps of doing it. And even if you don't want to do it, you can just say dismiss. So if I do not want to ever have a service health alert on this subscription, then doesn't have to see it in my recommendations for the end of time. So that's Azure Advisor, really useful tool for saving money, improving performance, improving security, and following best practices. Now, we saw that one of the advisor recommendations was to create alerts within Service Health. So Service Health is another one of the dashboards inside of Azure. This one is talking about Azure services as a whole and not specifically your services. So whereas Azure Advisor is going to look at your services, this is going to look at the Azure platform. So we can see if there are any service issues currently ongoing. I can see there's even an alert for one emerging issue. So they're investigating an issue with Azure in the UK region. So there's an emerging issue that's being investigated. When there are issues that actually end up happening, then we can see them listed here. Now, I can set up an alert to let me know when there are issues that might affect me. So let's say I want to get an alert every time there's an issue that could be affecting the Canadian region, which is sometimes where I put my resources. You know, I don't know if you want to have all issues for all platforms. Maybe you're large enough to require that. But in my particular case, let's say I know that most of my resources are going to be in the Canadian region, and I only want to be alerted for the Canadian region. You could even filter it down so that you're only being told about computing issues or database issues and not necessarily all issues. But this might be, I might not get a lot of alerts if I really filter this down. I also can see whether I want to know about active service issues, any kind of planned maintenance, other kinds of security and health advisories. So let's see, I don't mind all that. Also, we do recommend the global region. So let's also make sure that global is selected. All right, so I can set up an alert. This can go to one of the action groups that's going to have an email and SMS message in my case. I don't mind that. Or I can have quick actions that happen, or maybe nothing can happen. This is a resource, and so this rule is going to get stored into a resource group. I give it a name. I'm going to call this Service Health Canada. I don't need to put any tags on it. And if I was to create this, I would start getting alerts anytime there's any kind of service issue or planned maintenance or other in the Canadian region and in the global region. So as you can see, I'm not going to do this right now. I'll go back to Service Health. As you can see, it's basically a dashboard for Azure-wide, region-wide issues. And you can see it on a map here. We can see lists of planned maintenance if there's any planned maintenance coming up. In this case, there's not. We can see a history of these events. So maybe going back in time, if we chose a 3-month range, we can see different events that have happened in the last 3 months across the world. So Service Health is where you go to track and monitor and set alerts for Microsoft Azure issues. And the last tool we'll talk about, and pretty much the end of the course, is Azure Monitor. Now, Azure Monitor is sort of a centralized dashboard of all of the logging and analytics across your account. So let's actually go back. Let's create a web app just for fun here. Go into the marketplace, look for web apps. And this is a web app. I'm going to create a brand new web app for just the demo purpose. Give it a name, EasySJD web app. I'm going to choose it as a .NET 7 web app running on Windows. Easy enough. I'll leave that in East US. And we'll just take the default here, standard S1 plan. Okay. We don't need a database with it. I'm going to leave all the standard settings. We're not going to enable GitHub. We're not going to put this on a virtual network. We're going to allow public access. The tab that we're interested in is this monitoring tab. Now, Application Insights is enabled by default, and it's going to create a brand new Application Insights instance for this. We can see the bracket says bracket new. And so what this is going to do is it's going to enable application performance management on this application. It's going to automatically monitor the application. It'll detect anomalies. It's going to basically collect data from this application. So like if users are using it and they're encountering errors, or the application is slow or things like that, that kind of stuff will be tracked automatically by Application Insights. Let's go ahead and create this. $99 per month. Now, what's going to happen? It does take a little while, not only for this app to be created. I'm going to have to deploy an app into it. That's going to have to get used. Data collection is not instantaneous. But what is eventually going to happen? I'm going to let that run, and we're going to go back to Azure Monitor here. You can see that one of the options is Application Insights, and I even see it on the left here. So I can go into the Application Insights section of it. Now, right now there are no, because it's still in the process of being created. But once this application gets created and applications get deployed to it, we're going to start to see Application Insights apps visible within Azure Monitor. And then within there, we're going to be able to look at reports and see how this app has been performing and any kind of errors that have been raised and issues with the app. So this is just an example of using this Azure Monitor, using some of these plugins to get data out of apps, out of virtual machines, out of storage accounts, containers, networks, SQL database, Cosmos DB. You can see all of the different Azure services that it supports, and it can pull in the performance and the health issues into a dashboard. And it's one place within Azure where you can basically monitor everything across your whole account. All right, so beyond connecting many different compute and database and storage types into Azure Monitor in order to gather the data, you have a few ways of viewing the data. The two that I want to dial in on are the logs view and the metrics view. We're going to start with the logs view. So when you click on logs within Azure Monitor, you're able to see some particular options in terms of queries. I'm going to change the scope here. So right now I'm looking at app services. I know we just added one, but let's close this out. I'm going to minimize this. And what I want to do is I want to select the scope. And because we just created the web app, it's not going to be ready for us to run queries on it just yet. I want to look at storage accounts because I know I have those, and they've been collecting data for a while, so we can run various reports on storage accounts. So I go under select scope, and then I go down under resource types, and I say storage accounts. Okay, that's the one that I want for now. It's going to show me my subscriptions and my resource groups. I know I have a storage account underneath the AZ900 resource group, and so I'm going to focus only on this storage account. It's in West US 2, and I'm going to say apply. So now any queries that I run are entirely against this storage account's data. We can see on the left, so I've minimized the menu for monitor, and I'm focused on the little menu for this query window. If you are familiar with SQL Server Management Studio at all, you might recognize the query editor here. It's very similar in design. You've got your run query in the top right, you've got your results in the bottom right, and along the left you have effectively what are your list of tables. So since I'm focused on storage account, the only options being shown to me are storage account tables. I can see activity table, metrics table, and blob logs table. I'm not going to be, this is just for the case of this Azure Monitor logs. Now, there's also a bunch of pre-built queries. And so if I go down to this storage, here's one for usage. I can look for, session duration, stuff like that. I'm going to group by resource type instead. And now I can go down to see the storage accounts. And so there are a bunch of pre-built queries. I can see errors. I can see anonymous requests, which are the most frequent operations. So I'm going to say load to editor for frequent operations. So we've got a query in the top right part of the screen here. Now, this is not SQL. The language that's being used in this query for Azure Monitor is called Kusto, K-U-S-T-O, and the language is KQL. And so this is slightly different than SQL. It's got a different syntax and a different format here. We can see the name of the table as being the first word. So we go back to tables. We saw storage blob logs is a table. And then we can use various modifiers. There's a pipe symbol, and then there's the where modifier. There's the pipe symbol, the summarize modifier, sorting, and how I want this rendered. So we can see on screen it's 3 days. It's going to basically look for operations used over the past 3 days against this storage account. Now, I don't know. I've never actually run this report recently, so I don't know what it's going to come up with here, if it's going to work first time. But I live dangerously, and I'm just going to click Run. So it says no results found from the specified time range. So obviously for this 3 days, it's not finding in storage blob logs. I do not know if I actually have a storage blob logs being stored. I'll show you how to find that out actually. So if we go back to the home, I can go into my resource group. There's the storage account we were just looking at. And I'm going to go down under monitoring, and I can see what logs. This is the same report access in terms of logs. Let's see what's being collected. So right now it is collecting the reads, writes, and deletes, as well as the transactions, and being kept it into a log analytics workspace. If I go back under logs, and this is the same option that we had under Azure Monitor, by the way, I can go back down to resource type, go back down under storage. Let's look at, right, back to storage blob logs. Now I know that under tables, I'm going to delete this here, that we have metrics for this storage account. So I'm going to say, let's say for the last 4 hours, I can change it here in the top, or I can put it as part of the query. And I'm going to run. And I want to see all metrics over the past 4 hours. Now I can see basically every 10 minutes, roughly, at 10:28, 10:36, 11:17, it's going to be pulling which type of metrics, number of transactions, how much data was brought in, how much data went out, the availability of the storage account. There appears to be 4 types of data being pulled every 10 minutes from this storage account. So you can see the logs has a pretty cool way of basically writing custom queries or using some pre-built queries to pull data and then do your analysis and see how your resources are performing. The other thing that I wanted to show you, let's go back to monitor, and was this metrics tab. Now we just saw that the metrics table had data for that storage account. I'm going to go under I'm going to pick the same storage account as the scope and say apply. Now I can have multiple storage accounts all under the same scope. I can't mix storage accounts and compute and other things into the same scope, but all the same resource types can go in the same. And let's say I want to see the availability on average over the past 24 hours. All right, I can see that this is 24 hours of data. Let's say I want to see 7 days of data. So my storage account has had 100% availability constantly over the past 7 days, which is great. So we can see here that we can create charts, we can get the raw data, we can run queries, filter stuff out. If I wanted to, I can save this chart to my dashboard, and when I log into Azure every time, I'll see the availability of that particular storage account. Let's look at amount of data leaving the storage account. Now we can see here there was a spike at 3:30 in the morning where somebody came and took a little bit more data from that account than the other times. So I don't know what was happening there, but there was a lot of data being pulled at that moment over the last 7 days. Let's see if I can change this to 30 days. Back in March 21st, there was a really big spike of 350 kilobytes, which doesn't seem like much. So there we go. Anyways, that's the metrics tab. You can see some graphs. Logs tab, you can run some queries. Azure Monitor allows you to see what's going on in your storage account across many, many different storage types and, run those reports on it. Well, that's it. Congratulations. Thank you so much for making it to the end of the course. I've been so grateful to be helping you get through the Microsoft Azure AZ900 material to learn all the great things that this platform can do. And I'm confident that you're able to go and book your AZ900 test if that's what you wish. Book that for some days in the future. And maybe you can do a couple of more things of studying before we go ahead and take that test. For instance, there are a couple of practice tests in this course. So you can go ahead and find those two practice tests that are listed in the course. I also have another course on Udemy that is got another set of practice tests, 3 additional practice tests if you're so inclined. As well as there's a PDF study guide. So if you want to get some reading material to read up on all of the topics of this course, I have a booklet for that, as well as all of the slides of the course. So thank you so much again for being here. I'm so grateful for you. If you would be so kind as to leave a review so that other students can find this course and know that it helped you studying, go ahead and book the exam. I think you're going to do great. This has been Scott Duffy from Get Cloud Skills. Thanks again, and have a wonderful day.